You're standing in a museum looking at a Neanderthal skull, and you're realizing something nobody told you. It's bigger than the one inside your head. Not by a little. Neanderthal brains averaged around 1,410 cubic centimeters. Yours is closer to 1,350. Some Neanderthal skulls pushed past 1,600, a full 250 cubic centimeters larger than a typical modern brain. You've heard it your whole life. Humans have the biggest brains. That's why we're the smartest. There's just one problem. It isn't true. The average human brain has shrunk by around 10% over the past 20,000 years, roughly 100 to 150 cubic centimeters across the global record. But in some populations, the drop was even sharper. One study of European females found brain size fell from around 1,502 cubic centimeters to 1,241 over just 10,000 years, a reduction of 240 cubic centimeters, about the size of a large lemon, in a geological instant. That rate of shrinkage was nearly 36 times faster than the brain grew during the previous 800,000 years of human evolution. Not in one place. 19 independent peer-reviewed studies across Europe, Africa, Asia, Australia, and the Americas all found the same thing. About a tennis ball's worth of brain gone. And the part that should bother you, this was happening right as civilization was getting more complex. Cities, writing, large-scale farming. If anything, you'd expect brains to get bigger. They didn't. The brains that built the first cities were larger than yours. The brains that forged the first tools, wrote the first words, raised the first monuments. All larger than yours. Nobody agrees on why. And the leading theories are stranger than you'd expect. Before we get to the theories, let's be precise about what we actually know. We know that average brain volume has been declining. We know it's been documented on every inhabited continent. We know the reduction is real enough that 19 separate research teams over nearly 90 years all independently found it. What we don't know, and this is important, is exactly when the sharpest drop happened, or why. Some researchers say the decline began around 35,000 years ago, at the tail end of the last ice age. Others say the most dramatic drop happened much more recently, within the last 3,000 to 5,000 years. That would place it squarely in the era of early civilization, the Bronze Age, the first writing systems, the first cities. One peer-reviewed paper proposed exactly that, and then another paper challenged it. And then the original team responded. The argument is still ongoing. So what we're dealing with isn't a mystery that science has solved and simply hasn't told you about. It's a genuine open question, one that's been sitting in the scientific literature for nearly a century, that most people have never heard of, and that the people who study it for a living still can't fully explain. That should tell you something about how strange this is. Here's the question you're probably already asking. Does smaller mean stupider? And the honest answer is, not necessarily. But the reason why is more interesting than the reassurance itself. The human brain is not a simple container where more volume equals more intelligence. It is one of the most metabolically expensive organs in biology, making up about 2% of your body's mass while consuming around 20% of its energy. A bigger brain is not automatically a better brain. It's an enormously costly one. Consider, elephant brains are larger than human brains. Sperm whale brains are larger than human brains. What matters isn't the raw volume, it's the organization inside it. The density of connections, the efficiency of the wiring, the ratio of gray matter to white matter, the structure of specific regions. And here's the thing, a smaller, more efficiently wired brain might actually perform better at certain tasks than a larger, more expensive one. Evolution doesn't select for raw size, it selects for survival. If a smaller brain can do the same job with less fuel, that's an advantage. So, our brains shrank doesn't necessarily mean we got dumber, but it does mean something changed, something significant enough to reverse a 2 million-year evolutionary trend. And whatever caused it, that's the part nobody has fully explained. The first theory is the simplest, and in some ways the most satisfying. Our brains shrank because our bodies shrank. Brain size and body size are not independent. Bigger animals tend to have bigger brains. It's a scaling relationship that holds across species, and it holds within species too. As human bodies became smaller, which they did significantly over the Holocene, you'd expect brains to follow, and indeed, some of the brain reduction does appear to track body size reduction. The timing overlaps. The proportions are at least partially consistent. But here's the problem. The math doesn't fully work. When researchers run the numbers, body size reduction explains some of the brain shrinkage, but not all of it. The brain appears to have reduced faster and further than body proportions alone would predict, which means body size is probably part of the story. It may not be the whole one, something else was happening, maybe more than one thing. The second theory starts with a question. What if the brain didn't shrink because something went wrong, but because something got smarter? The human brain is running on a budget. 20% of your body's total energy constantly, whether you're thinking hard or sitting still. That's an enormous cost. In an environment where food was often scarce, that cost had real consequences for survival. Now imagine that over time, through better tools, better social organization, better food storage and preparation, that pressure eased. Calories became more reliable. The extreme metabolic pressure that had been driving brain expansion for 2 million years started to lift. If the pressure driving brains bigger disappeared, you'd expect natural selection to start trimming the fat. Literally, a smaller brain that does the job adequately costs less to run. In evolutionary terms, that's not a failure. That's a refinement. This is the efficiency hypothesis. The brain didn't shrink because humans got less capable. It shrank because maintaining that much cognitive hardware became less necessary for survival, and the energy savings were worth more than the extra volume. It's a plausible story. And like every other theory on this list, it doesn't fully account for the timing, the scale, or the speed of the change. This is where it gets genuinely strange. There is a pattern in biology called the domestication syndrome. When you take a wild animal and domesticate it, dogs from wolves, pigs from boars, cattle from aurochs, a cluster of traits tends to appear together. Reduced aggression, smaller teeth, floppier ears, smaller body size. And consistently, reliably across almost every domesticated species. Smaller brains. It happens every time. Domesticated pigs have brains roughly 18% smaller than wild boars. Dogs have significantly smaller brains than wolves. The pattern is so consistent that researchers can use brain size to tell a domesticated animal from a wild one. Now here's the part that should stop you cold. When anthropologists look at the human skull record over the past several thousand years, they find the same cluster of changes. Smaller teeth, less robust bones, reduced sexual dimorphism, and smaller brains. The hypothesis that follows is called human self-domestication. The argument, developed extensively by Harvard evolutionary biologist Richard Wrangham, is that human societies, over time, began selecting against their most violently aggressive members. Not through formal systems, but through collective action. Groups conspired to remove or exclude individuals who were too dangerous to tolerate. The most aggressive males left fewer descendants. Over generations, the population became, on average, less reactive, more cooperative, more socially tolerant. And as a side effect of selecting for calmer, more cooperative behavior, brain size decreased, the same way it always does when you domesticate an animal. The implication, if this is correct, is extraordinary. You may be a domesticated version of your own species, tamer than your ancestors, less aggressive, and in at least one measurable sense, smaller-brained. The fourth theory is the one that keeps researchers up at night, because it's the one that implies the smallest brains might actually be the cleverest. It starts with ants. In eusocial insect colonies, ants, bees, termites, researchers have observed something counterintuitive. As colony size increases and tasks become more specialized, individual brain size can actually decrease. Each worker needs to be good at fewer things. The intelligence of the colony doesn't live in any one brain. It lives in the network. A team of researchers at Dartmouth and other institutions looked at the timing of human brain reduction and noticed something striking. The sharpest apparent drop coincided with a period of rapid growth in human social complexity. More people living in closer proximity, division of labor, specialized knowledge, and, critically, the invention of writing. Their proposal, as human groups became larger and more interconnected, cognitive tasks that once had to live inside individual brains could be distributed across the group and eventually stored outside the body entirely. No single person needed to know how to do everything. Knowledge could be shared, divided, and offloaded. Writing didn't just record information, it may have changed the brain's job description. If this theory is correct, the shrinking human brain isn't evidence of cognitive decline. It's evidence of cognitive redistribution. Individual brains got smaller because they no longer had to carry the full weight of human intelligence alone. The weight moved into the network, into the group, the community, the written record. Which means the civilization you live in isn't just something your brain built. It might be something your brain partially outsourced itself to. Here's where the intellectual honesty matters. None of these theories has won. All of them have evidence. All of them have critics. And the timing question, exactly when the sharpest reduction happened, is still being actively argued between research teams publishing responses to each other as recently as 2023. What we can say with confidence, the human brain is measurably smaller than it was during the late Pleistocene. The reduction is real. It's been documented too many times by too many independent teams in too many different populations to dismiss. What we cannot say with confidence, why it happened, whether it's still happening, or whether smaller means anything for human capability in any direction. This is the honest picture, and the honest picture is, if anything, stranger and more interesting than a simple answer would be. Because what we're looking at is a reversal of one of the most fundamental trends in the history of life on Earth. The 2 million-year march toward a bigger, more capable brain. And we genuinely don't know what turned it around. Before we go further, here's the question I want you to think about. Of the 4 theories, body size, metabolic efficiency, self-domestication, collective intelligence, which one bothers you the most? Drop it in the comments, because the answer says something interesting about how you think about what intelligence actually is. Step back from the skull measurements and the competing theories for a moment. What we're actually looking at is a species that spent 2 million years becoming something, building a brain of extraordinary complexity and cost, and then, at the very moment it started using that brain to build civilization, something began to reverse. Whether the cause was bodies getting smaller, energy getting cheaper, aggression getting selected out, or intelligence getting distributed into a network, in all 4 cases the story is the same at its core. The world changed, and the brain changed with it. That's what evolution does. It doesn't optimize for intelligence in the abstract. It optimizes for survival in the specific environment that exists right now. The brain that was perfect for tracking prey across an open savanna, for surviving an ice age in a small band with no backup, for carrying everything you knew inside your own skull because there was nowhere else to put it, that brain was solving a different problem than the brain you need today. And somewhere in that transition, the most expensive organ in your body quietly started to shrink. Not because you got worse, because the world got different. You started this video with a brain that is, by the available measurements, smaller than the brains of the people who first painted cave walls, first buried their dead with flowers, first looked up at the night sky and tried to name what they saw. And yet you're here, watching this, in a world of 7 billion interconnected minds, with 10,000 years of written knowledge available at your fingertips, in a civilization so complex that no single human brain could hold even a fraction of how it works. Maybe the brain didn't shrink because something was lost. Maybe it shrank because something was built that could carry some of the weight. The minds that painted those cave walls were alone with everything they knew. Their knowledge lived in them, and when they died, most of it died with them. Yours doesn't have to. The question is whether what we've built outside our heads is actually worth what quietly disappeared inside them. Nobody has answered that yet.
And if that question is the kind of thing that keeps you up a little later than you planned, there's another one waiting for you right after this.